After this video, you will never forget whether the arithmetic mean is bigger than the geometric mean or the other way around. The picture makes the answer permanent. It is arithmetic mean greater than or equal to geometric mean. Now, name the four important points. A and B are the endpoints of the diameter. D splits that diameter into the two pieces A and B. C sits on the semicircle above D. And O is the center, exactly in the middle of the diameter. Here I will use one lemma, as already known. The altitude CD is the geometric mean of AD and DB. I already made two separate proof videos for that fact, and one more video on Euclid's classical construction of the mean proportional. So this video will focus on the comparison with the arithmetic mean instead. So after accepting that CD is the geometric mean, only one real question remains. Why is OC the arithmetic mean? Once you see that, the inequality sign becomes almost automatic. Start with the whole diameter. AB is made from the two pieces AD and DB. So the total diameter is A plus B. That sounds trivial, but it is exactly the quantity whose half becomes the arithmetic mean. Now comes the crucial identification. O is the midpoint of the diameter AB, so AO and OB are each half of AB. But O is also the center of the semicircle, so OC is a radius, and every radius has the same length. Therefore, OC equals OA equals OB, and each of them equals 1/2 of AB. Since AB is A plus B, OC is A plus B over 2. That is exactly the arithmetic mean. Now the picture becomes wonderfully simple. Look at triangle ODC. It is a right triangle with the right angle at D. Inside that triangle, OC is the hypotenuse and CD is just one leg. So the radius is automatically at least as long as the altitude. And that is why the sign can no longer be confusing. Arithmetic mean is the radius, or if you like, the hypotenuse. Geometric mean is the altitude, or if you like, the leg. The hypotenuse is the longer object. So it has to be arithmetic mean greater than or equal to geometric mean, never the reverse. Now ask when equality can happen. In a right triangle, the hypotenuse is strictly longer than a leg unless the other leg vanishes. So for OC to equal CD, the remaining side OD must shrink to 0. Geometrically, that means D must slide onto O. But when D overlaps O, the two diameter pieces on the left and right are the same. Then AD equals DB. In the labels of this problem, that means A equals B. So arithmetic mean equals geometric mean only in the symmetric case where D sits exactly at O, which is exactly when A equals B. This way of comparing arithmetic mean and geometric mean is genuinely classical. Greek mathematicians were already thinking in means long before symbolic algebra. The Pythagorean tradition knew the inequality in geometric language. Archytas gave a famous classification of arithmetic, geometric, and harmonic means, and Euclid later treated the mean proportional as a construction problem. What makes this semicircle method so satisfying is that it turns an inequality of numbers into a comparison of two visible lengths in one picture. So here is the whole memory in one line. The altitude CD is the geometric mean, the radius OC is the arithmetic mean, and in the right triangle ODC, the radius is the hypotenuse, while the altitude is only a leg. That is why arithmetic mean is greater than or equal to geometric mean. If you want the dedicated proof that CD equals square root of AB, go watch the 2GM proof videos and the Euclid construction video. But for the inequality sign itself, this one picture should be enough forever.